we will look at evaluating limits at infinity. Limits at infinity means limit x approaches to infinity, f of x, and the limit x approaches to negative infinity, f of x. Both of these limits, the first thing that we need to do, if it is you have to take leading term over leading term, if it is possible. Sometimes leading terms can't be identified. If it is possible to identify leading terms, we will take leading term over leading term. What do you mean by sometimes we can identify, sometimes not? Let's look at it. Say I have something like 4x squared minus 7x plus 8x cubed minus 1000 divided by this problem. Now tell me what is the leading term in the numerator. The leading term in the numerator, leading term is the term with the highest exponent, the term with the highest degree. So that would be 8x cubed and over 4x cubed, and that is, you can cancel out x cubes and you will have 8 over 4, no excess, no need to write the limit, so the answer would be 2. There is no difference if it is x is approaching to negative infinity, you still take the leading terms. What's happening here, after canceling the leading terms, the variables, you got x, you can't have x in the answer, so no x is supposed to be the answer. No x or limiting variable in the answer. You can never have x or limiting variable. Limiting variable means if x is approaching to negative infinity, that's a limiting variable. If a is approaching to some value, a would be the limiting variable. So you cannot have limiting variable in the answer. So you can't have x in the answer. If you plug in negative infinity for x, you get 3 over 2 times negative infinity, so that would be your answer. The same way, if you have backwards, something left over on the bottom, so you still continue the same thing, finding leading terms on the top and bottom. When you simplify this time, you are going to have an x on the bottom. Proceed to plug in, so that is something 3 over negative infinity. When you divide a number by a large quantity, your answer would be very close to 0. So when you divide a number by absolutely big number, which is infinity, so it's going to be very, very negligible small number, which is 0. Next thing we will see, how do you evaluate radicals? What is square root of 9? What is square root of x squared? What is square root of 16? What is square root of 16a squared? If there is no variable inside the radical, you take the principal root. This is called a principal root. Principal root is always positive. You take the positive quantity. But if there is a variable inside, you take plus or minus. Same way here, square root of 16 would be 4. But because the variable inside, you get 4, 16 is a positive 4 square root, but a squared, square root of a squared would be plus or minus a. Hence, you will get a plus or minus 4a. At the same time, if you have x squared equals 9, if you take square root on both sides, I get square root of x squared equals square root of 9. This is actually plus or minus x equals 3. That means positive x equals 3 or negative x equals 3, which means x equals negative 3. So in an equation, if a variable is involved, then yes, we do take plus or minus. That's not because square root of 9 is plus or minus 3. It's because square root of x squared is plus or minus x. Let's apply square root concept onto this. We know square root of 4x squared is plus or minus 2x. So when I say this one, limit x approaches to infinity, we could identify 4x squared is the leading term here, meaning square root of 4x squared. So you say negative, and square root of 4x squared is a plus or minus 2x, but x is approaching to infinity, that's a positive quantity, so square root of 4x squared would be positive 2x. So positive 2x, but this negative is coming from here, divided by 2x, that would be negative 1. Whereas this one, negative 4x squared, square root of 4x squared would be negative 2x here, because x is approaching to negative infinity, and that would be positive 1 because that's a 2x over 2x, and you must write limit here because you still have variable, and that would be positive 1 because you can cancel those two. So limits involving absolute values, if there is no indeterminate format, you just simply plug it in. So it's simply you replace x with the limiting value, which is 5, and if I plug in, that's absolute of negative 3, which is positive 3, and you are done. That's the answer. But some cases you may have indeterminate formats. For example, this one. So if I plug in x equals 3, I get 0 over 0, which is indeterminate, and I can't have answer indeterminate, so I have to do something. To do that, first of all, you need to decide, you need to understand what's the definition of absolute value. If I ask you in class, what is absolute of 3, you would say definitely 3. Absolute of negative 3 is a positive 3 as well. You are perfectly correct. But at the same time, as soon as I ask you what is absolute of x, 99.99% of you are going to say x. Now this definition is wrong. Why is this wrong? Let's see. You said absolute of x equals x. Now let me plug in x equals 3, and then my x value here is 3, my x value here is 3, and that's a correct statement. Now look at the other situation where x is not positive number anymore. What if I have x is negative 3? Like this. Then according to your definition, I'm just filling out x's. Your x value is negative 3. I'm just filling 4x. And your x here is supposed to be negative 3, which means absolute of negative 3 equals negative 3. We know this is a wrong definition. So that means there is something wrong in our definition. Absolute of x is not just x. Absolute of x is plus or minus x. I'm not saying absolute of 4 is plus or minus 4. That's not what I'm saying. If you have a variable inside, you have to say plus or minus. Why is that? This is what the definition of absolute is. Absolute of x is x. if x is more than 0, equals opposite of x if x is less than 0. It does not matter where you put equal sign. All absolute functions are piecewise functions. Now let's see if this definition holds good if I plug in x equals negative 3. X equals negative 3 falls under second piece. So absolute of negative 3 would be opposite of x. So negative of negative 3, which becomes positive 3. So if x is a positive value, then take the same value. That's what you are saying. Take the same value without any change. But if x is a negative value, take the opposite of it to make it positive. So that's the definition of absolute value. In conclusion, if I have 2x plus 3 absolute, I have to say that is plus or minus 2x plus 3 when I get rid of the absolute value sign. But at the same time, I'm not saying absolute value of 4 is plus or minus 4. You need to understand the difference between those two very clearly. Now let's apply what we learned now. So when I plug in 0 over 0, we know absolute of x minus 3 is not just x minus 3, is supposed to be plus or minus x minus 3. So we are going to do left and right limits. This is another condition. If you have absolute limits, then if it's indeterminate, then must do left and right limits. Then do left and right limits. So x approaches to 3 from the right side, absolute of x minus 3 over 3 minus x. Now this is what we decide. 3 from the right side, give me a number, say 3.1. If I plug in inside 3.1, do I get a positive number or negative number? Because it's a positive number, you don't take plus or minus, you take plus x minus 3 over 3 minus x. You can factor out negative on the bottom or the top, it doesn't matter. You take negative on the bottom, so you get x minus 3, because when you distribute, you should get the same. Those two cancel, and the answer is that. Whereas this side, it would be, you take the left side of 3, a value, which is 2.9. If I plug in that, I get negative value. Because it's a negative value, to make it positive, I have to have a negative outside. The definition of absolute, x minus 3 divided by 3 minus x. If I distribute that negative on the top that we have, you get negative x, positive 3, or 3 minus x is the same thing. You cancel those two, and you get negative 1, positive 1. So left side value is a negative, right side value, left side value is a positive, right side value is negative. Hence, this limit does not exist.